Hello there, and welcome. Tonight, we are going on a long, slow journey through the strangest things the universe is known to hold. Stars so large they would swallow half the solar system. A dead star made of diamond. A planet that is evaporating into a tail 9 million kilometers long. An asteroid with a date and a 4% chance of hitting our moon. Some of what you will hear sounds impossible. All of it is real. And for every one of them, I will tell you how we know. Before we begin, I would love to know where you are listening from tonight and what time it is where you are. Leave it in the comments if you are still awake enough to type. And if these journeys help you rest, a like and a subscribe take 2 seconds, and they genuinely help this small channel. That is all. Now make yourself comfortable. Dim your screen. Let your shoulders soften and your breathing slow. There is no test in the morning and nothing you need to remember. If sleep takes you halfway through, that is exactly how this is meant to work. The largest star we have ever measured is called Stephenson 218. It sits about 20,000 light-years away, hidden behind the dust of our own galaxy. It is roughly 2,000 times wider than the Sun. Numbers that large stop meaning anything, so picture it another way. If it replaced the Sun tomorrow, its surface would swallow Mercury, Venus, the Earth, Mars, the asteroid belt, and Jupiter. It would reach on towards Saturn. We would be inside it, somewhere deep in the glow. Astronomers argue about the exact size because the star is faint and far, and the dust confuses the measurement. But even the smallest estimate is enormous. The biggest things in the sky are the hardest ones to measure. Up close, the largest stars are barely there at all. A red supergiant's outer layers are stretched so thin that they are emptier than the air in your bedroom. If you could fly into one, you would pass through a warm, glowing haze for a very long time before anything solid appeared. Astronomers know this from the star's mass and its size. Divide one by the other, and the average density comes out lower than a laboratory vacuum. The heat sits in the core. The rest is fog. So the biggest objects the universe builds are mostly empty space, wrapped around a small, furious heart. One star survived its own explosion, and people watched it happen. Eta Carinae lies about 7,500 light-years away. In 1837, it began to brighten, and by 1843, it was the second brightest star in the sky. Sailors in the southern seas used it to steer by. It stayed bright for around 20 years, then faded. During that eruption, it threw off something like 10 suns worth of material. Any ordinary star would have died. Eta Carinae did not. Today, we can see the cloud it made. 2 lobes of dust expanding at millions of kilometers per hour. The star is still inside, still burning, and astronomers expect it to explode properly one day. In late 2019, one of the brightest stars in the sky started to fade, and nobody knew why. Betelgeuse, the red shoulder of Orion, dropped to about 1/3 of its usual brightness by February 2020. People began to wonder whether it was about to explode. It was not. In 2021, astronomers using the Very Large Telescope in Chile published the answer. The star had thrown off a cloud of gas. The gas cooled into dust, and the dust blocked part of its light from our direction. It was a curtain, not a death. Betelgeuse recovered within months. When it does finally explode, it will be bright enough to see in daylight, but that may be 100,000 years away. When a star exploded in 1987, 3 detectors on Earth felt it before anyone saw it. The star was in the Large Magellanic Cloud, about 160,000 light-years away. On the 23rd of February 1987, detectors in Japan, the United States, and Russia recorded a burst of neutrinos lasting about 13 seconds. 2 to 3 hours later, telescopes saw the light. The neutrinos won because they escaped the collapsing core immediately, while the light has to fight its way out through the star. 24 particles. That is all they caught. But those 24 particles confirmed how a star dies, and they founded a new kind of astronomy. Some stars beat like hearts, and one woman worked out how to read them. They swell and shrink over hours or days, brightening and dimming in a steady rhythm. In 1908, Henrietta Leavitt, working at Harvard on photographic plates, noticed the pattern. The slower a star pulses, the brighter it truly is. That one rule turned these stars into measuring sticks. Read the rhythm, and you know the real brightness. Compare that with how faint it looks, and you know the distance. Edwin Hubble used her rule to prove that other galaxies exist. When astronomers say a galaxy lies 70 million light-years away, the number rests on Leavitt's work. Perhaps half of all stars live in pairs, and some of those pairs feed on each other. When 2 stars orbit close enough, one begins to pull gas off the surface of the other. Astronomers call it mass transfer. A thin stream of glowing material arcs across the gap between them. The receiving star grows heavier and brighter and lives a strange second life. The other is slowly stripped, sometimes down to its bare, burning core. We can watch this happening. The pattern of light from the pair changes in ways that match the theft exactly. There are stars in our galaxy tonight being taken apart by their own companions. In the crowded centers of old star clusters, stars sometimes collide and merge. The result is easy to spot. A bright blue star appears among neighbors that are 10 billion years old, looking far too young for the company it keeps. Astronomers call these blue stragglers. They were first noticed by Alan Sandage in 1953 while he was studying the cluster M3. For decades, nobody knew where they came from. Now we think most of them are 2 stars that fell together and became one, wearing an age they did not earn. Such meetings are almost unimaginably rare on human timescales. But the galaxy has had billions of years to arrange them. When a massive star runs out of fuel, the end takes less than a second. The core, heavier than our sun, collapses from roughly the size of the Earth to the size of a city. It happens faster than you can blink. In that instant, the matter reaches the density of an atomic nucleus, and the collapse stops so abruptly that a shockwave is born. That shockwave tears the rest of the star apart. Hold that against its life. 10 million years of steady, patient burning, finished in under a heartbeat. If you were watching from a safe distance, there would be a star, and then there would be an explosion, and nothing in between. A single dying star can briefly outshine an entire galaxy. For a few weeks, a supernova can radiate more light than 100 billion ordinary stars put together. Astronomers routinely find them in galaxies so distant that nothing else in the picture is visible. One death, bright enough to cross half the universe. And the violence is generous. The blast scatters freshly made elements across thousands of light years. Iron for future blood, and calcium for future bones. The shockwave squeezes nearby gas clouds until they collapse into new stars. A supernova destroys one sun and helps to build the next 1,000. The brightest explosions in the universe were discovered by satellites looking for nuclear tests. In the 1960s, the United States launched a series of spacecraft called Vela to watch for Soviet weapons in violation of a test ban treaty. In 1967, they started picking up flashes of gamma rays. The flashes were not coming from the Earth. They were coming from deep space. The finding was kept classified for years and published in 1973. We now know these are gamma ray bursts, the death cries of massive stars, and the collisions of dead ones. The most violent events since the Big Bang were found by people looking for something else entirely. On the 9th of October 2022, a burst of gamma rays hit the Earth so hard that it disturbed our atmosphere. Astronomers named it GRB 22109A and nicknamed it the Boat, the brightest of all time. It came from about 2 billion light years away, and it saturated the detectors of every gamma ray telescope in orbit. Instruments designed to measure such bursts simply could not keep up. Down here, receivers noticed a change in the ionosphere, the electrically charged layer of our upper atmosphere. A star died 2 billion years ago, and the Earth's atmosphere flinched. Astronomers estimate an event that bright arrives roughly once every 10,000 years. Our own sun will never explode, and we have already photographed what will happen instead. It is too small for a supernova. In about 5 billion years, it will swell into a red giant, swallowing Mercury and Venus. Then it will let its outer layers drift away into space like smoke, leaving a fire. Those layers will glow for a while as a planetary nebula, a soft ring of color light years wide. There are thousands of them in the sky, and each one is a star doing what ours will do. What remains at the center will be a white dwarf. The sun's old heart shrunk to the size of the Earth, cooling quietly for the rest of time. Taken together, these stars show a universe that builds on a scale the human mind was never made for. The largest of them are wider than the orbits of planets and thinner than the air in a bedroom. Some live only a few million years and end in a single second. Others survive their own explosions and keep burning. And all of it reaches us as faint points of light, softened by distance into something calm enough to sleep under. A white dwarf is the exposed core of a dead star, and it burns nothing at all. It holds roughly the mass of the sun in a ball the size of the Earth. It shines only because it remembers being hot. The nearest famous one is Sirius B, which circles the brightest star in our sky. It was found in 1862 by Alvan Graham Clark while he was testing a new telescope lens. Here is the strange part. White dwarfs cool so slowly that not one of them anywhere has finished. The cold, dark ember they are all heading toward does not yet exist in the universe. 13.8 billion years was not enough time. There is a dead star made of diamond. It drifts 50 light years away in the constellation Centaurus. Astronomers call it BPM 3793, but they nicknamed it Lucy after the song about diamonds in the sky. As the star cooled, its carbon core hardened into a single crystal. Astronomers worked this out in 2004 by listening to the star. White dwarfs ring like bells, and the pattern of their vibrations reveals what is inside. That crystal holds about as much mass as our sun. In carats, the number is 10 billion trillion trillion. It is not a diamond anyone could wear. It is a diamond you could orbit, and our own sun will end the same way. A teaspoon of neutron star would weigh about 4 billion tons. When a heavy star dies, it leaves a core about 20 kilometers across, holding more mass than the sun. Inside it, atoms have been crushed out of existence. Protons and electrons are pressed together into a sea of neutrons, matter with all the empty space squeezed out. 4 billion tons is roughly every building in a large city pressed into the bowl of one spoon. If you could somehow bring that spoonful here, nothing would hold it. It would fall through the floor, through the crust, through everything. Matter like that cannot exist on Earth. Out there, whole stars are made of nothing else. On a neutron star, the tallest possible mountain is less than a millimeter high. The gravity is so strong that nothing tall can stand. In 2021, a team of physicists modeled the crust and calculated the limit. Anything higher than about a millimeter is crushed flat by the star's own weight. So a neutron star may be the smoothest object in existence. Its entire mountain range would hide under a grain of sand. And there is a way to check. A spinning neutron star with a real bump would send out gravitational waves, and our detectors would hear a steady hum. So far they have heard nothing. The silence is the evidence. One dead star spins 716 times every second. It is a pulsar called PSR J1748-2446 AD, found in 2004 in a cluster about 18,000 light years away. Say that slowly. An object heavier than the sun, the size of a city, turning twice as fast as a kitchen blender. And it holds that pace for millions of years, barely slowing. Its equator is moving at nearly a quarter of the speed of light. If you could hover nearby and watch, you would not see a sphere at all. You would see a blur, humming in the dark like a struck tuning fork. The most reliable clocks in nature are dead stars. Many spinning neutron stars fire beams of radio waves from their magnetic poles. As the star turns, the beams sweep across space like a lighthouse. When one crosses the Earth, our telescopes record a pulse, then another, then another. Jocelyn Bell Burnell found the first one in 1967, and the signal was so regular that her team briefly labeled it LGM-1 for Little Green Men. Some pulsars keep time well enough to rival atomic clocks, losing less than a second over decades. Astronomers now use them to navigate, to weigh invisible companions, and to test Einstein. Tonight, hundreds of them are sweeping their beams straight through your house. The first planets ever found outside our solar system circle a dead star. In 1992, Alexander Wolszczan and Dale Frail were listening to a pulsar called PSR B12. Its pulses arrived very slightly early, then very slightly late, over and over. Something was tugging the corpse in circles. Planets, at least 3 of them, orbiting the remains of an exploded sun, bathed in radiation rather than sunlight. This came 3 years before the first planet was found around a normal star. It was a strange overture to the age of exoplanets, and a useful one. Planets do not need gentle suns. They can form or reform in the harshest places there are. A magnetar is the strongest magnet in the universe, and one of them once hit the Earth from halfway across the galaxy. These are dead stars with magnetic fields trillions of times stronger than our planet. On the 27th of December 2004, a magnetar called SGR 180620 cracked its own crust. The flash crossed 50,000 light-years, compressed the upper atmosphere of the Earth, and knocked several satellites into safe mode. For 1/5 of a second, it was brighter than the full moon in gamma rays. Only about 30 magnetars are known, and all of them are safely far away. The strongest forces in the universe are kept in its smallest objects. Most of the gold in the universe is made when 2 dead stars collide. On the 17th of August 2017, humanity watched it happen. 2 neutron stars merged in a galaxy about 130 million light-years away. Detectors felt the shaking of space, and within hours, 70 observatories had turned to look. In the glowing wreckage, astronomers read the signatures of freshly made heavy elements. Among them was gold, hundreds of Earths worth of it, created in moments and thrown into the dark. The Earth did not make its gold. It only caught it long ago as it drifted between the stars. When 2 black holes collide, they shake the shape of space itself. Einstein predicted this in 1916 and then said we would never be able to measure it. He was nearly right. On the 14th of September 2015, 2 detectors in America called LIGO felt a tremor from 2 black holes that had merged 1.3 billion years ago. The tremor stretched a 4-kilometer tunnel by less than 1,000th of the width of a proton. That is the smallest thing human beings have ever measured. To manage it, the engineers had to filter out passing trucks, distant earthquakes and waves hitting the coast. Since then, the detectors have felt hundreds more. Some weeks they catch several. Together, these dead stars reveal that endings out there are not quiet. What a star leaves behind can be a diamond the size of the Earth, or a city-sized ball so dense that a spoonful outweighs a mountain range. It can keep better time than an atomic clock, or hold a magnetic field strong enough to reach across the galaxy. Nothing simply stops. It changes into something stranger and keeps going. There is a black hole at the center of our galaxy, and every star you have ever seen is circling it. It sits 26,000 light-years away, behind the star clouds of Sagittarius, and it holds 4 million times the mass of the Sun. We know its mass because astronomers tracked individual stars orbiting it for nearly 30 years. Andrea Ghez and Reinhard Genzel shared the Nobel Prize for that work in 2020. In 2022, the Event Horizon Telescope published its photograph, a ring of orange light around a core of nothing. And here is the surprise. It is calm. It barely feeds. It simply sits there, holding the galaxy together, while the sun carries us around it once every 230 million years. Black holes do not pull in everything around them. This is the thing almost everyone gets wrong. If the sun were replaced tonight by a black hole of exactly the same mass, the Earth would not be pulled in, not even slightly. Gravity depends on mass, and the mass would be unchanged. The Earth would keep the orbit it has now, circling a darkness about 6 kilometers wide. It would be cold and dark, but nothing would fall. A black hole only takes what wanders close, and close is much nearer than people imagine. The one at the center of our galaxy has been sitting there for billions of years without eating the Milky Way. Some black holes wander the galaxy alone, and one has finally been caught. They are thrown out by 3 body encounters, or kicked away by the recoil of their own mergers. In 2022, astronomers confirmed the first free-floating example, about 5,000 light-years away. They found it because it drifted in front of a distant star, and its gravity bent that star's light, brightening it for months. The measurement took 6 years of Hubble observations. Statistically, our galaxy should hold millions more, threading silently between the stars. None are near us, but it changes the feel of the map, knowing that some of the travelers out there carry no light at all. When a star drifts too close to a giant black hole, it is pulled into a long, glowing ribbon. The black hole's gravity tugs far harder on the near side than the far side, and the star is stretched until it comes apart. Astronomers with straight faces call this spaghettification. Half the ribbon escapes into space at enormous speed. The rest spirals inward, heating as it falls, and flares brighter than the whole galaxy around it for months. Telescopes now catch several of these flares every year, and some stars survive. Astronomers have found cases where a star skims past again and again, losing a little each time and flaring on a schedule. The brightest objects in the universe are powered by black holes. When a giant black hole feeds, the matter spiraling into it heats to millions of degrees and begins to shine. That glow is called a quasar. One feeding black hole can outshine every star in its galaxy put together, hundreds of billions of suns at once. Martin Schmidt worked out what they were in 1963, when he realized that a strange object called 3C 273 was not a nearby star, but something enormous and far away. You can find 3C 273 with a backyard telescope. Its light is about 2 billion years old when it reaches the eyepiece. Feed-in black holes fire jets of matter across millions of light years. Magnetic fields around the whirlpool grab part of the infalling material and shoot it out from the poles at nearly the speed of light. The jet from the galaxy M87 was photographed in 1980 by Heber Curtis, who described a curious straight ray and had no idea what he was seeing. In 2024, astronomers announced a pair of jets they named Porphyrion, stretching some 23 million light-years. That is more than 200 Milky Ways laid end to end, produced by an object smaller than our solar system. One black hole has been holding the same note for 2 billion years. In the Perseus cluster of galaxies, 250 million light-years away, a giant black hole is pushing pressure waves through the hot gas around it. Pressure waves through gas are sound, and that cluster is one of the few places out there where sound can travel. In 2003, astronomers measured the pitch using the Chandra X-ray telescope. It is a B-flat, 57 octaves below middle C. That is far beneath the lowest key of any piano, and 1,000,000 billion times too deep for human ears. It is the deepest note ever detected, performed for an audience of 1,000 galaxies. The biggest black holes are so large that light needs days to cross them. The old record holder is a quasar called Ton 618, with something like 66 billion times the mass of the Sun. Its event horizon is wider than our entire solar system. In 2026, astronomers announced a pair of black holes in a galaxy called Abell 402 BCG with a combined mass near 60 billion suns, the heaviest pair ever found. These objects are invisible. We know them only by the blazing whirlpool of matter around the darkness. You could pour every star you have ever seen into one and barely change its weight. Near a black hole, time itself slows down, and this has been tested on real clocks. Einstein's equations say gravity slows time, and beside an event horizon, the effect becomes extreme. Watch a clock fall toward 1, and you would see it tick slower and slower until it seemed to freeze at the edge, fading from view. For the clock, nothing strange happens. It falls straight through. Someone hovering just above that edge, engines straining, would look up and see the rest of the universe running fast. Whole ages would flicker past in what felt to them like hours. Time is not the same everywhere. It bends around weight, like everything else. Your phone corrects for Einstein every second of every day. The clocks on GPS satellites orbit 20,000 kilometers up, where the Earth's gravity is weaker, so they run fast by 38 millionths of a second each day. It sounds like nothing, but navigation works by timing signals, and without the correction, your map would drift by about 10 kilometers a day. Within a week, or it would be useless, so the engineers correct it, constantly and quietly. Every time your phone finds your street, a prediction Einstein made in 1915 has been tested again and passed again in your pocket. Your head ages faster than your feet, and this has actually been measured. Einstein's rules say that clocks higher in a gravitational field run faster. In 2010, physicists at the American Standards Laboratory, NIST, compared two of the finest atomic clocks ever built, placed just 33 centimeters apart in height. The higher clock ran fast, exactly as predicted. By 2022, the same effect had been measured across a single millimeter. Over a whole lifetime, the difference between your head and your feet adds up to a few hundred billionths of a second. Nothing you will ever feel. And notice what you do by lying down. For a few hours, your whole body keeps the same time. These ideas about black holes and time all point the same way. Black holes are not vacuum cleaners and not villains. They are places where mass is packed so tightly that space and time bend around them. The effects are not exotic. They run in your phone every day, and they were measured between two clocks 33 centimeters apart. The extreme and the ordinary turn out to be the same physics, seen from different distances. On Neptune and Uranus, it rains diamonds. Thousands of kilometers beneath the calm blue cloud tops, the pressure tears methane apart and squeezes its carbon into crystal. The diamonds then sink slowly toward the core. This is not a guess. In 2017, physicists at the SLAC laboratory in California recreated the conditions with a powerful laser. They compressed plastic to the right pressure and watched nanodiamonds form in a fraction of a second. The experiment was repeated with better materials in 2020, so the physics holds. On two worlds you can find with a garden telescope, it is raining gemstones into an interior no one will ever see. There is a planet where the rain is molten glass and it falls sideways. HD 189733b lies 63 light-years away in the constellation of the Fox. In 2013, astronomers used Hubble to measure its true color and found a deep ocean blue, the same shade Earth shows from far away. But the color is not water. It comes from clouds of silicate, molten glass, floating in air heated toward 1,000 degrees. The winds there blow at thousands of kilometers per hour, several times the speed of sound. The glass does not fall so much as fly, horizontally, forever, around the whole planet. There is a planet that is evaporating, and it leaves a tail behind it, like a comet. It is called BD plus Eris-5 4868 Oibul, about 140 light-years away, found by the TSS telescope, and announced in 2025. Its year lasts 30.5 hours. It orbits so close to its star that the surface is being vaporized, and the vapor streams away into space. The tail stretches around 9 million kilometers, roughly half the way around its own orbit. Astronomers found it because the tail blocks starlight in a way no solid planet could. It is a world being written out of existence, and we caught it in the act. There is a world where ice is hotter than fire. Gliese 436b sits about 30 light-years away and circles its small red star every 2.5 days. Its surface bakes at several hundred degrees. Yet its mass and size tell us that most of its bulk is water. Not water as we know it. Under the crushing weight of the planet's gravity, water is squeezed into exotic solid forms that stay locked and crystalline no matter how hot it gets. Ice you could not touch. Ice that would burn your hand. We grow up believing that fire beats frost. Press hard enough, and water freezes in an oven. There is a planet darker than coal. TRES-2b is a gas giant the size of Jupiter, about 750 light-years away. In 2011, astronomers using the Kepler telescope measured how much light it reflects. The answer was less than 1%, darker than black acrylic paint. Nobody is entirely sure why. Its atmosphere seems to swallow light and give almost nothing back. It circles its star closely, so it glows faintly with its own heat, a dull ember in an unlit room. Somewhere out there tonight, a world the size of Jupiter is crossing the face of its star, almost invisible even in full glare. Some planets are as light as candy floss, and NASA uses exactly that comparison. Around a young star called Kepler 51, astronomers found 3 planets nearly the size of Jupiter that hold only a few Earths worth of mass. Their density is close to cotton candy. They are almost entirely atmosphere, vast inflated shells of hydrogen around small hidden cores. Hubble measurements in 2019 confirmed how strange they are. They may be a passing phase, young planets still swollen with the heat of their birth, slowly deflating over millions of years. Planets do not come in a few standard models. The galaxy runs every experiment at once. On one planet, it rains iron. WASP 76b keeps one face permanently turned to its star, and that side reaches temperatures where iron turns to vapor. Winds carry the metal vapor around to the cooler night side, where it condenses and falls. Astronomers found it in 2020 using a telescope in Chile by watching the fingerprint of iron appear on one edge of the planet and vanish on the other. That is the signature of metal falling out of the sky. Molten iron rain, dripping through an alien midnight. Weather is universal. Only the ingredients change. There is a planet that orbits its 2 suns over their poles. Most planets circle their stars along a flat plane, the way the solar system does. In 2025, astronomers announced a world about 120 light-years away that goes over the top and under the bottom of its binary pair instead. Nobody expected such an orbit to be stable. The discovery came from measuring the wobble of the 2 stars, which shifted in a direction that only a polar orbit could explain. It is a reminder that our neat, flat solar system is one arrangement among many, and not necessarily the normal one. Saturn's rings are not the grandest we have seen. Around a young world known as J1407b, astronomers glimpsed what appears to be a ring system, some 200 times larger. It was found by accident in 2012, when a distant star dimmed in a complicated pattern for 56 days. Something enormous had passed in front of it. If those rings circled Saturn, they would stretch across our sky many times wider than the full moon. There seemed to be gaps in them too, the kind carved by newborn moons sweeping their paths clean. The interpretation is still debated, but we may have watched satellites being assembled inside a ring. Saturn's rings are disappearing, and the dinosaurs may never have seen them. The ice that forms them is constantly pulled down onto the planet as a slow, glittering drizzle that astronomers call ring rain. Measurements from the Cassini spacecraft suggest the rings are losing enough material to fill an Olympic swimming pool every half hour. Cassini brought a stranger gift too. The rings appear to be young, perhaps only tens of millions of years old, formed from a moon or comet that was torn apart. So we are alive during a brief age, when the solar system's finest ornament is switched on. Saturn would float. Its average density is about 0.69 grams per cubic centimeter, which is less than water. No other planet in the solar system can make that claim. In a bathtub wider than the distance from the Earth to the Moon, Saturn would bob like an apple, with its rings glittering above the waterline. The planet is large enough to swallow more than 750 Earths, and still, spoonful for spoonful, it is lighter than rainwater. Saturn is mostly hydrogen and helium, the two lightest substances there are, wrapped around a small heavy core. Saturn has a hexagon at its north pole. It is a six-sided jet stream about 30,000 kilometers across, wide enough to hold two Earths side by side, with winds racing along each straight edge. Voyager glimpsed it in 1981. When Cassini arrived a quarter of a century later, it was still there. 6 crisp corners drawn on a ball of gas. It even changes color with the seasons, from winter blue to summer gold. Nothing built it, and nothing maintains it. Scientists have made small versions in the laboratory by spinning tanks of liquid, and 6 sides appear on their own. No other planet we know has one. Together, these worlds show that our solar system is not the standard. Planets can rain diamonds or molten iron, evaporate into comet tails, or hold ice that stays frozen in an oven. They can circle 2 suns, or wear rings 200 times larger than Saturn's. Every time astronomers expected a rule, the galaxy produced an exception. Nature does not build to a plan. It builds every version at once and keeps them all. Venus is not the closest planet to the Sun, yet it is by far the hottest. The surface sits at about 465 degrees, hot enough to melt lead. The cause is its carbon dioxide atmosphere, which traps heat in a runaway greenhouse that never lets up, day or night, pole to equator. Its day is longer than its year. It takes 243 Earth days to turn once, and 225 to circle the Sun. It also spins backwards, so its sun rises in the west. And on its highest peaks there is frost made of metal, vaporized in the lowlands, and condensed on the cooler summits. On Mercury, there are places where the sun rises, stops, goes backwards, and then rises again. The planet turns 3 times for every 2 orbits, and its path around the Sun is stretched rather than circular. Near its closest approach, the planet's orbital motion briefly outpaces its own rotation. Seen from certain spots on the surface, the Sun halts in the sky, reverses for a few Earth days, then resumes. Astronomers call it the Caloris effect, after the huge basin below. A day there, from one sunrise to the next, lasts about 176 Earth days. Time on Mercury does not behave the way it does anywhere else. The tallest mountain we know is on Mars, and you could not see it from its own slopes. Olympus Mons rises about 22 kilometers, 2.5 times the height of Everest. Its base would cover an area the size of Arizona. The slopes climb so gently across such impossible width that a traveler standing on them would find the summit hidden beyond the curve of the planet itself. It grew for perhaps 1 billion years, lava layered on lava. Mars has no drifting continents to carry a volcano away from its source, so the pile just kept climbing. Jupiter's moon, Io, is the most volcanic world in the solar system, and it never chose to be. It is caught in a tug of war, with Jupiter pulling one way and the neighboring moons pulling the other. Its solid ground rises and falls by tens of meters every orbit. All that flexing becomes heat, and the heat has to escape. More than 400 volcanoes answer, some throwing fountains of sulfur hundreds of kilometers into space. Io repaints its entire surface faster than anywhere else we know. It has no ancient craters because nothing on it stays old. Voyager found the first eruption in 1979, and it has not stopped since. On Titan, you could fly by flapping your arms. Saturn's largest moon has air half again as thick as ours, and gravity 7 times weaker. With wings strapped to your arms, a person could genuinely fly there under muscle power, the way we fly in dreams. You would need a heated suit because Titan sits at 179 degrees below zero. The rain drifting past you would be liquid methane, falling in slow, oversized drops into rivers and cold black seas. The Huygens probe landed there in 2005 and sent back the sound of wind. Somewhere in our own solar system, there is a world where flying is easy. One small moon is leaking its ocean into space. Enceladus is only 500 kilometers across, but from 4 great cracks near its south pole, it fires geysers of water and ice hundreds of kilometers upward. Some of that spray settles into orbit and feeds one of Saturn's rings. Cassini flew directly through the plumes and tasted them. It found salt, silica, and organic molecules, the chemistry of a warm seafloor. So under the bright frozen shell, there is a global ocean, kept liquid by the endless flexing of Saturn's tides. A moon you could drive across in a day, venting its sea into space like breath on a cold morning. The largest oceans we know of have never seen daylight. Beneath the cracked ice of Jupiter's moon, Europa, there may be twice as much water as in all the seas of Earth. Inside Ganymede, the biggest moon in the solar system, there is likely another. These oceans have been dark for 4 billion years, warmed from below, roofed over by kilometers of ice. Recent work has complicated the picture. A study published in 2026 suggests Europa's ice shell may be a stronger barrier than we hoped, which matters because 2 spacecraft are on their way there now. When you find Jupiter in the sky tonight, that steady, bright point, you are looking toward shorelines that have never once seen light. The galaxy is full of planets that belong to no star. Some were thrown out of their birth systems in early gravitational fights. Others formed alone in collapsing clouds. Astronomers find them by chance, when one drifts in front of a distant star, and its gravity briefly magnifies that star's light. The counts suggest billions of them, possibly more worlds without suns than with them. On such a planet, there is no sunrise, no year, and no seasons. And yet some may hold warm oceans locked under deep shells of ice, heated from within by their own radioactive hearts. The galaxy's largest population may be its quietest one. The Earth has a second companion, and a spacecraft is arriving there right now. Kamoa-Liwa is a small asteroid, perhaps 60 meters across, that has followed our planet for about a century. Its surface reflects light the way lunar rock does, which suggests it may literally be a chip knocked off our own moon by an ancient impact. China's Tianwen-2 mission launched to find out and reaches it this year, with samples due back on Earth in late 2027. The Earth also captures temporary moons now and then, small boulders that circle us unnoticed for a few months and then slip away. There is an asteroid that is mostly metal, and it may be the naked core of a world that never finished forming. Psyche is about 280 kilometers across and sits between Mars and Jupiter. Radar and density measurements suggest a mix of iron, nickel, and rock, unusually rich in metal for an asteroid. The leading idea is that a young planet had its rocky flesh stripped away by collisions, leaving the heart bare. NASA's Psyche spacecraft launched in 2023 and arrives in 2029, not to mine it, but to look, because nobody has ever seen the inside of a world from the outside. Europa's ice may be a thicker door than we hoped. The moon almost certainly hides a global ocean beneath its frozen shell. And that ocean is the most promising place in the solar system to look for life. The hope was always that cracks in the ice would carry material up from below, so a spacecraft could sample the ocean without drilling. Work published in 2026 complicates that. The cracks appear to freeze shut within hours, and the shell may be a stronger barrier than assumed. 2 missions are on their way there now, and they will have to answer this question when they arrive. Every planet in the solar system would fit in the gap between the Earth and the Moon. That gap averages about 384,000 kilometers. Line up Mercury, Venus, Mars, Jupiter, Saturn, Uranus, and Neptune side by side, and they fit with a little room to spare. Jupiter alone is 140,000 kilometers across, and it still fits with company. The moon looks close. It looks like a lamp over the garden. It is far enough away to swallow every world we have in single file. The moon is drifting away from us, and we know the rate to the millimeter. It recedes about 3.8 centimeters a year, roughly the speed your fingernails grow. We can measure this because Apollo astronauts left mirrors on the surface in 1969 and after. Observatories still fire lasers at those mirrors and time the reflection. Because the moon keeps receding, total solar eclipses have an expiry date. In a few 100 million years, it will look too small to cover the sun, and the last perfect eclipse will end the show. We happen to live in the narrow age, when the 2 disks match. 400 million years ago, the Earth's day was about 22 hours long, and fossil corals proved it. Certain corals lay down one fine ridge of growth every day, and one thick band every year. In the 1960s, the paleontologist John Wells counted the daily ridges inside a single year's band in corals 400 million years old. He found about 400 of them, not 365. The year had not changed. The day had. The moon's tides have been slowing our spin ever since, stretching the day out toward the 24 hours you live in now. The evidence was growing quietly on the sea floor the whole time. Our own neighborhood turns out to be the strangest place of all, because we can check it. There are volcanoes taller than the sky is deep, moons leaking their oceans into space, and an air thick enough to fly in. There is a companion asteroid that may be a piece of our own moon, and corals on Earth that counted the days when the days were shorter. All of this sits inside a few light hours of home. There is a cloud near the center of our galaxy that would smell of raspberries. In 2009, astronomers pointed a radio telescope at a gas cloud called Sagittarius B2 and looked for the fingerprints of molecules. Every molecule absorbs and emits radio waves at its own frequencies, so a telescope can read chemistry from 26,000 light years away. Among the signals they found ethyl formate, the molecule that gives raspberries their flavor and rum its smell. The same cloud holds ordinary drinking alcohol too, billions of liters of it, frozen onto grains of dust. Nobody brewed any of it. It is just carbon chemistry doing in the galaxy what it does in a kitchen. Our galaxy is laced with rivers of stars, and each one is a galaxy that was eaten. When a small galaxy strays too close, the Milky Way pulls it apart and stretches it into a stream tens of thousands of light years long. The Sagittarius stream loops right over our galactic poles, the ghost of a dwarf galaxy still being devoured. The Gaia spacecraft, which measured the positions and motions of nearly 2 billion stars, has revealed dozens more of these faint currents. Each is the ruin of something that no longer exists, still flowing along the path where it died. Some of the stars overhead tonight were not born here at all. The whole galaxy is falling towards something we cannot see properly. The Milky Way, and everything in it, including you, is rushing through space at more than 2 million kilometers per hour. It is falling toward a concentration of mass astronomers called the Great Attractor. It lies inside a continent of galaxies named Laniakea, a Hawaiian word meaning immeasurable heaven, mapped in 2014. We cannot see our destination clearly because it sits behind the dust of our own galactic disk. You feel none of this because everything you know is falling with you, smoothly, in the same silent direction. The sun is moving at about 828,000 kilometers per hour, and you cannot feel any of it. It carries every planet with it as it circles the center of the galaxy. That is nearly 1,000 times faster than a passenger jet. One full lap, one galactic year, takes roughly 230 million Earth years. The last time we passed through this part of the galaxy, the dinosaurs were only beginning. Their entire reign, from first footprint to last, fitted inside a single lap. You will travel more than 6 million kilometers before morning and wake up exactly where you left your shoes. The Milky Way you can see is the smaller part of the Milky Way. Around the visible galaxy lies a vast halo of dark matter that outweighs all the stars, gas, and planets combined, several times over. It gives off no light and absorbs none. We know it is there because the stars in the outer galaxy orbit far too fast. Vera Rubin measured this in the 1970s, galaxy after galaxy, and found the same thing every time. Without extra unseen mass, those stars would have flown off into the dark long ago. Most of every galaxy is made of a substance nobody has ever directly detected. Some galaxies never turn their lights on. Astronomers have found vast swirls of gas and dark matter with almost no stars in them, invisible to ordinary telescopes. They show up when their gravity bends the light of something behind them, or when radio dishes hear their cold hydrogen. One example, Dragonfly 44, glows with less than 1/100th of the Milky Way's light, yet its stars move as if something far heavier is holding them. The measurement has been argued over since 2016 and revised more than once. That argument is the point. When you see a photograph full of shining galaxies, it only shows the ones that chose to glow. When one galaxy falls straight through the middle of another, the impact rings outward like a stone dropped in a pond. A circular wave of compressed gas spreads through the disk, igniting into new stars as it goes. The result is a ring galaxy, a blazing hoop of young blue suns around a nearly empty center. The most famous is the Cartwheel, 500 million light-years away, still glowing from a bullseye strike around 200 million years ago. Webb photographed it in 2022 and showed the dust and young stars in detail. The rings do not last. They spread, they fade, and the galaxy settles into something ordinary. Some stars are being thrown out of the galaxy and will never come back. A close pass by the central black hole can act as a slingshot. One star of a pair is captured, and the other is flung outward with the stolen energy. In 2019, astronomers clocked one called S5HVS1 at nearly 1,800 kilometers per second, over 6 million kilometers per hour. Tracing its path backwards showed it left the galactic center about 5 million years ago. Imagine standing on a world beside such a star, ages from now. No Milky Way overhead. Only distant galaxies, small and pale, in every direction. 70,000 years ago, another star passed through the edge of our solar system. It is a dim red star, now called Schultz's star, traveling with an even fainter companion. In 2015, astronomers measured its speed and direction and ran the clock backwards. It came within about 1 light-year of the Sun, brushing the Oort cloud where our comets live. Humans were here. Our ancestors were making tools and tending fires. The star would have been too faint for most eyes, though its flares may have made it briefly visible. It is 20 light-years away now, and still leaving. Once in a very long while, the stars call on each other. In the year 774, something struck the Earth from space, and every tree alive that year wrote it down. In 2012, the Japanese physicist Fusa Miyake was examining ancient tree rings and found a sudden surge of radioactive carbon in the single ring for that year. Cedar in Japan showed it. Oak in Europe showed it. One planet-wide signature, pressed into wood. The best explanation is a solar storm far beyond anything seen in the satellite era. No chronicle records a disaster. People simply live through it, under a sky that may have glowed strangely for a night. Only the trees noticed, and they kept the receipt for 1,200 years. In 1859, a solar storm set telegraph offices on fire. On the 1st of September, the English astronomer Richard Carrington was sketching sunspots when he saw 2 points of white light flare on the sun's surface. Hours later, the Earth was hit. Auroras appeared as far south as the Caribbean, bright enough to read a newspaper by at midnight. Telegraph lines sparked. Some operators disconnected their batteries and found they could still send messages, powered by the storm alone. Others were shocked by their own equipment. That was 1859, when the most advanced electrical system on Earth was a wire on a pole. In 1908, something exploded over Siberia and flattened 2,000 square kilometers of forest without leaving a crater. It happened on the 30th of June, near the Tunguska River. 800 million trees were knocked down in a radial pattern, all pointing away from the center. The blast was heard hundreds of kilometers away, and the pressure wave was recorded on instruments in England. No expedition reached the site until 1927, and when they did, they found the trees at the center still standing upright, stripped of branches. The best explanation is a rock or comet fragment that exploded in the air before it could touch the ground. 2.5 million years ago, a nearby star exploded and the Earth walked through the ashes. The proof is still here. Iron-60 is a radioactive form of iron made only in supernovae. It lies buried in the deep ocean crust, in seafloor sediments, and in soil brought back from the moon. All of it dates to the same ancient rain of dust. Our ancestors on the African plains would have seen the explosion, a new star burning in their night for months, perhaps visible even by day. They had no way of knowing its remains were drifting down around them. Part of the sky is at the bottom of the Pacific. 3 times now, something has arrived from another star. The first was Oumuamua in 2017, on a path no object of ours could produce. Then came the comet Borisov in 2019, and in 2025 came 3Y Atlas, which turned out to be the strangest of all. Webb measured its chemistry in December 2025 and found about 30 times more heavy water than in any comet of ours. The carbon told the same story. The comet appears to have formed 10 to 12 billion years ago, when the universe was young and star formation was at its peak. Something older than the sun, older than the Earth, passed by while we were watching. Astronomers comparing old sky photographs with new ones have found stars that are simply missing. Points of light present on survey plates from the middle of the last century are absent from modern images. A project called VASCO has catalogued around 100 of these vanishings. Stars are not supposed to do this. They end loudly in explosions or fade over ages, not between one photograph and the next. Most will turn out to be flaring stars or flaws in the old plate. But the honest answer today is that nobody knows. And astronomers keep the list precisely because unexplained things are worth keeping. Some stars are being eaten slowly, one bite at a time. When a star falls into a black hole, it is usually destroyed in a single flare. But astronomers have now found stars on stretched orbits that skim past the black hole again and again. Each pass tears away a little material, which heats up and flares. Then the star swings out, comes back, and it happens again. Some of these systems flare on a schedule, which is how they were identified. It means a star can survive an encounter with a black hole and then return to it over and over for years. Together, these facts show that the galaxy is not a backdrop. It sends things. It sends dust from exploded stars into our ocean floor, radiation into the rings of trees, and comets older than the sun through our own solar system. It sends stars wandering past our doorstep and pulls whole galaxies apart into rivers. We are not watching the galaxy from outside. We are living inside its weather. None of this is happening far away. As you lie there, the universe is passing through the room. Cosmic rays, Atomic fragments thrown out by supernovae and feed-in black holes hit the atmosphere above you every second. Some of their descendants reach the ground and pass through the walls and through you without stopping. Apollo astronauts, above the atmosphere's shelter, saw them as tiny flashes of light inside their closed eyes. And gentler still, about 100 trillion neutrinos from the heart of the sun stream through your body every second. Tonight the sun is on the far side of the planet, so they rise up through the floor, through the mattress, and continue on. The beginning of the universe used to visit our living rooms. In 1964, two engineers, Arno Penzias and Robert Wilson, could not get rid of a faint hiss in their radio antenna. They cleaned it, they checked the wiring, and they evicted the pigeons nesting inside. The hiss stayed, coming from every direction, day and night. It was the afterglow of the Big Bang, light released when the universe was 380,000 years old, stretched by expansion into microwaves. On an old analog television tuned between channels, a small part of the dancing static was exactly this. The oldest light there is, arriving in your living room, mistaken for nothing. Every time you look up, you are looking into the past. Light is fast, but not instant. The moon you see is a second and a half old. The sun is 8 minutes old. Sirius is 8.5 years old. The light of the pole star is about 400 years old. It left home around the time Galileo first lifted a telescope, and it has been traveling every moment since. The deeper a telescope looks, the older the light gets, until the faintest smudges in its images are older than the Earth. There is no now in the night sky. Every star sits at its own depth in time. In 1995, an astronomer pointed the most valuable telescope in the world at nothing, and it worked. Bob Williams chose an empty patch of sky near the Big Dipper, about the size of a pinhead held at arm's length. Other astronomers thought he was wasting precious time. He kept Hubble's shutter open for 10 days. The nothing turned out to hold about 3,000 galaxies. Not stars, galaxies, each with billions of suns, stacked behind one another into the deep past. Every empty patch of your sky holds the same hidden crowd. Emptiness, examined patiently enough, has never once turned out to be empty. The Webb telescope keeps finding galaxies that look too grown up for their age. When it began sending back images of the early universe, astronomers expected small, ragged clumps still assembling themselves. Instead, they found galaxies that appeared surprisingly massive and orderly only a few 100 million years after the Big Bang. Some looked older than the universe should have allowed. The explanations are still being argued. Recent work suggests part of the answer is hidden populations of small, faint stars, which could make some of these galaxies 3 to 4 times heavier than first estimated. Either way, galaxies grew up faster than our models said they should. The largest reservoir of water ever found is not on any world. It is a cloud of vapor wrapped around a quasar called APM 08295255, 12 billion light-years away. Two teams announced it in 2011. The cloud holds about 140 trillion times the water in all of Earth's oceans, warmed by the black hole it surrounds. Because its light took 12 billion years to reach us, we are seeing that water as it was when the universe was less than 2 billion years old. Water is not a latecomer. The same simple molecule in the glass beside your bed was already drifting in enormous clouds before the sun existed. In 2024, astronomers found a black hole hiding in plain sight in one of the most photographed objects in the sky. Omega Centauri is a globular cluster visible to the naked eye from the southern hemisphere, holding about 10 million stars. Researchers went back through 20 years of Hubble images and tracked the motions of individual stars near its center. 7 of them were moving far too fast to be held by the visible mass. Something unseen and heavy is in there. The evidence had been sitting in an archive for 2 decades, waiting for someone to measure it carefully enough. The coldest place we know of is not empty space. It is a cloud of gas escaping a dying star, and the escape itself makes it cold. The Boomerang Nebula sits 5,000 light-years away, and its gas is expanding so fast that the expansion chills it to 1 degree above absolute zero. It is the same physics that makes a spray can grow cold in your hand, that makes this cloud colder than deep space, because even the emptiest space is faintly warmed by the afterglow of the Big Bang. Astronomers measured it in 1997. The coldest known place in nature is a deathbed, radiating away its last warmth. One nearby star briefly appeared to be older than the universe. HD 3 sits only about 200 light-years away, and early measurements put its age near 14 billion years. The universe is 13.8 billion years old. Astronomers called it the Methuselah star and set about finding the mistake. Better distance measurements have since brought it down to around 12 billion years, comfortably inside cosmic history. But the lesson holds. This star formed from nearly pristine gas when the universe was young, before the sun, before the Earth, before the Milky Way finished assembling. And it is still shining tonight, close enough to be called a neighbor. The oldest solid objects anyone has ever held fell out of the sky onto a sheep paddock. In 1969, a meteorite broke up over the Australian town of Murchison. Inside it, scientists found pre-solar grains, microscopic crystals of silicon carbide, forged in the outflows of dying stars. In 2020, a team dated some of them to about 7 billion years ago. That is billions of years before the sun existed. Those grains drifted through the galaxy, survived the sun's violent birth, were locked inside rock, and finally landed in a paddock where somebody picked them up. Some of the past is not gone. It is sitting in museum drawers. In the late 1990s, astronomers set out to measure how fast the universe's expansion was slowing down and discovered it is speeding up. 2 rival teams found the same thing by measuring exploding stars in distant galaxies. The result was so unexpected that both teams spent months trying to find their own mistake. They shared the Nobel Prize in 2011. Something woven into empty space pushes outward, and it grows stronger as space grows larger. It was named dark energy, a name that is an honest confession of ignorance. Add up the accounts and everything ever seen, every star and every person, fits inside about 5% of the universe. Almost every atom in your body was forged inside a star. The hydrogen came from the Big Bang itself and is as old as time. Everything else was built later. The carbon in your skin and the oxygen you are breathing were made in the cores of dying stars. The calcium in your bones came from the same place. The iron in your blood was scattered by supernovae. The heaviest traces, the iodine in your thyroid and the gold in a wedding ring, were hammered out in collisions of neutron stars. Astronomers mean this literally, atom by atom. Generations of stars had to live and die before a planet could grow something like you. The nearest star to the Sun has a planet in its habitable zone. Proxima Centauri lies 4.2 light-years away. In 2016, astronomers announced a world circling it, a little heavier than Earth, at the right distance for liquid water. They found it by watching the star wobble as the planet tugged on it. Its year lasts 11 days. It probably keeps one face turned to its star forever, so one side is permanent day and the other permanent night. Nobody knows whether it has air or water or anything at all. But it is the closest thing to another Earth we have found. And in cosmic terms, it is next door. There may be a giant planet around the nearest sun-like star, and it keeps disappearing. In August 2024, the Webb telescope, using a mask to block the star's glare, saw a point of light beside Alpha Centauri A, 4 light-years away. It looked like a planet about the mass of Saturn. Webb looked again in February 2025 and in April 2025 and saw nothing. That is not necessarily a failure. If the planet is real and moving on the orbit they calculated, it would have been hidden behind the star's glare on both occasions. It should come back into view around August 2026. Astronomers are looking again now. These last ideas all lead back to the same place. The universe is not somewhere else. Its oldest light falls on your roof. Its particles pass through your body, and its atoms make up every part of you. The water beside your bed is older than the sun, and the calcium in your bones was made inside a star that died before the Earth existed. You are not separate from any of it. There is a galaxy in your sky tonight that you can see without a telescope. On a truly dark night, in the constellation Andromeda, your bare eyes can find a faint, elongated smudge of light. That smudge is a galaxy of 1 trillion stars, 2.5 million light-years away. It is the most distant thing a human eye can see unaided. Every photon finishing that journey into your pupil is older than our species. The Persian astronomer Al-Sufi recorded it in the year 964, calling it a little cloud, with no way of knowing what it was. Your eyes can see across intergalactic space, from a garden. Andromeda is coming toward us at about 400,000 kilometers per hour. In 4 to 5 billion years, the two galaxies will likely meet. It will not be a crash. Stars almost never collide in these events because the distances between them are too vast. Instead, the two spirals will swing through and around each other over billions of years until gravity braids them into a single enormous elliptical galaxy that astronomers already call Milkomeda. A study using Gaia data in 2020 put the odds nearer a coin flip than a certainty. which is a very astronomical kind of answer. Anyone alive then would watch Andromeda grow, century by century, from a smudge into a sky-filling spiral. There is an asteroid with a real chance of hitting the moon, and we know the date. It is called 2024 YR4, and it was found on the 27th of December 2024 by a survey telescope in Chile. For a few weeks, it looked as though it might hit the Earth, and the odds climbed high enough to make headlines. Then better measurements ruled the Earth out completely, but the Moon is still on the table. The European Space Agency puts the chance of an impact on the 22nd of December 2032 at about 4%. The rock is between 53 and 67 meters across. It is too faint to see now and returns to view in June 2028. There are worlds where the evening ends with 2 sunsets. Kepler 16b, about 240 light-years away, circles 2 stars at once. It was announced in 2011, and astronomers found it because the planet dimmed both stars in a pattern that only a circumbinary orbit could produce. From its cloud tops, one sun follows the other below the horizon, casting 2 sets of shadows in different shades. Nobody was sure such planets could form. The competing gravities seemed too violent. Kepler kept finding them anyway. Our single quiet sun turns out to be one arrangement among many. One of the brightest points of light in your sky tonight has people inside it. The International Space Station orbits 400 kilometers up and crosses the sky in a slow, silent arc, brighter than almost any star. No telescope is needed, only a clear evening and a timetable. It circles the Earth every 90 minutes, giving its crew 16 sunrises and 16 sunsets a day. It has been continuously inhabited since November 2000, which means that for a quarter of a century, humanity has never once all been on the planet at the same time. Someone is always up there, asleep, strapped to a wall. Space has a smell, and astronauts keep describing it the same way. When the airlock repressurizes after a spacewalk and the helmets come off, the suits and tools carry a sharp scent of hot metal, of seared steak, of welding fumes. The Apollo crews noticed it on the moon too. The dust they tracked into the lander smelled, they said, exactly like spent gunpowder. The vacuum itself carries nothing, of course. The smell is born in the airlock, most likely from lone oxygen atoms clinging to the suits and recombining when air returns. Fewer people have smelled it than have won an Olympic gold medal. Uranus quietly gained a moon in 2025. On the 2nd of February, the Webb telescope took a series of images of the planet, and hidden in them was a small object nobody had catalogued. It is only about 8 to 10 kilometers across, which is why Voyager missed it when it flew past in 1986 and mapped everything else. The discovery was announced in August 2025, bringing the count of Uranian moons to 29, a whole moon in our own solar system, sitting undetected until a telescope designed to study the early universe happened to look in the right direction. In April 2025, a spacecraft flew past an asteroid and found a shape nobody expected. NASA's Lucy mission was passing through the asteroid belt on its way to Jupiter's Trojan swarms when it took a close look at a rock called Donald Johanson. The pictures showed a wobbling object shaped like a peanut, apparently formed when two smaller bodies came together in a slow collision. Its rotation is being reshaped by sunlight, which pushes on an uneven surface, just hard enough over millions of years to change how it spins. Sunlight is not usually thought of as a force. Given enough time, it sculpts asteroids. On the 15th of August 1977, a radio telescope in Ohio heard something for 72 seconds, and then never again. The telescope was called Big Ear, and it was listening on autopilot. The signal was narrow and strong, and came from the direction of Sagittarius. It sat at almost exactly the frequency of hydrogen. The channel scientists had long guessed a careful civilization might choose. Days later, the astronomer Jerry Eman reviewed the printout, circled the sequence in red ink, and wrote one word in the margin: "Wow." Telescopes have returned to that patch of sky for half a century and heard only silence. Every ordinary explanation offered so far has had holes in it. The sun's atmosphere is hundreds of times hotter than its surface, and nobody fully knows why. The surface burns at about 5,500 degrees. The corona above it reaches 1 to 3 million. It is like walking away from a bonfire and feeling the air get hotter with every step. The suspects are known: magnetic waves carrying energy upward, and countless tiny flares detonating unseen. In December 2024, the Parker solar probe flew through the corona itself, 6 million kilometers from the surface, moving at 692,000 kilometers per hour. It is the fastest object humans have ever built, and it went there to settle this question. Sunlight is far older than it looks. The light warming your face left the sun's surface 8 minutes ago, and that part is true. But the energy in it was born in the core long before. A photon made, there is absorbed and re-emitted over and over in plasma, so dense that progress is measured in centimeters. Estimates for the journey out range from tens of thousands to 100,000 years or more. Only then comes the easy part: 8 minutes of open space, straight to your skin. The warmth of a sunny afternoon was manufactured while Ice Age humans were painting caves. At the frozen edge of the solar system, even the ice erupts. Neptune's moon Triton has one of the coldest surfaces ever visited, around 235 degrees below zero. When Voyager 2 flew past in 1989, it photographed geysers in action. Columns of nitrogen gas and dark dust rose 8 kilometers, then bent sideways in the thin wind and smeared dark streaks across the frost. Sunlight there is 900 times fainter than ours. Even that feeble scrap, trapped under translucent ice, is enough to build pressure and blow the surface open. Nowhere in the solar system is too frozen to move. The farthest object human hands have built is still calling home. Voyager 1 launched in 1977 with less computing power than a modern car key. It is now around 25 billion kilometers away, the first spacecraft to leave the sun's bubble and enter interstellar space. Its radio signal reaches us with less power than a refrigerator bulb and takes almost a full day to arrive. Antennas on 3 continents still lean toward it and listen. In 1990, at Carl Sagan's urging, it turned its camera around and photographed the Earth from 6 billion kilometers. A single pale blue dot, barely a pixel wide. Voyager carries a message, in case anyone ever finds it. Bolted to its side is a gold-plated record built to survive 1 billion years in vacuum. It holds greetings in 55 languages, and the sound of rain and heartbeats and whale song. There is music from Bach to Chuck Berry, and the recorded brainwaves of a young woman in love. Etched on the cover are instructions for playing it, written in the mathematics of hydrogen, the one language the universe shares. In about 40,000 years, Voyager will drift within 2 light years of another star. The record will still be readable then, long after every mountain range on Earth has worn away. There is no single now, and we have tested this on twins. Einstein showed that time runs at different rates depending on speed and on gravity. The astronaut Scott Kelly spent 340 days in orbit, while his identical twin brother Mark stayed on the ground. When Scott came home, he was measurably younger than he would have been, by a few milliseconds. Truly, physically younger. His year had simply run at a slightly different rate. The differences stay small, only because our lives are slow, and our gravity is mild. Every place and every speed carries its own time. This night belongs to you alone. Space is never truly empty. Between the planets blows the solar wind. Between the stars drift atoms, dust and molecules, thin beyond imagining, but never absent. Even the vacuum itself simmers with fields and fleeting particles at the smallest scales. Gravitational waves from colliding black holes are passing through this room tonight, stretching it by less than the width of an atom. Neutrinos are rising through the floor. The afterglow of the Big Bang is falling on the roof. Nowhere at any scale has anyone ever found true nothing. So you are not lying at the edge of a void. You are lying in the middle of everything. In 2026, the gravitational wave detectors caught a merger that should not have happened the way it did. A black hole and a neutron star spiraled together, which is not itself unusual. What surprised astronomers was the shape of the orbit. Almost every merger we detect has settled into a near-perfect circle by the time it happens, because gravitational waves smooth orbits out over millions of years. This one was still an oval. That points to a different origin story. Perhaps a chance capture in a crowded cluster rather than a lifelong pair. One detail in a signal, and a whole formation model has to be reconsidered. Neptune's inner moons may be the wreckage of an old disaster. They are a strange family, small and irregular, and crowded close to the planet. Unlike the tidy systems around Jupiter and Saturn, new Webb observations have added clues that these moons are not original. They look like the rubble of an earlier set of moons that were destroyed, perhaps when Neptune captured its large moon Triton and threw the neighborhood into chaos. Triton orbits backwards, which is itself a sign that it was captured rather than born there. The evidence is circumstantial, but the solar system keeps its accident reports in the shapes of what survived. And so our journey comes to an end. We have drifted from stars too large to imagine, past the diamond hearts of dead suns, through storms of glass and molten iron, out to the edge of everything light can reach, and back again to you. You do not need to hold on to any of it. The universe will keep every one of these facts safe while you rest. It has been keeping things safe for 13.8 billion years. Let your breathing slow now. Let the facts scatter like stars behind your eyes. If you are still awake, there is another journey waiting on your screen, and you are welcome to drift into it. And if there is something you would like me to explore slowly one night, leave it in the comments, and I will read it. But if your eyes are heavy, simply let go. The night is old and patient and very good at this. Sleep well, traveler. Good night.
Thank you.